Hello everyone, welcome to today's video. So today we are going to have a coding session and I'm very excited about it on the heap data structure that we learned in previous 3 videos. So if you have not already gone through those videos, I would highly recommend to please go through them. I'm putting a link in the description below in case you do not have that handy. And my recommendation is to please visit this video on coding only after you have gone through those 3 videos, right? So we are going to cover following things today in code. We are going to write a heap class. This will be like containing most of the functionalities. We would have gone through this in the first video if you would like to. Then there would be a PriorityQueue class. It will implement the functionality. And then we have a HeapSort class. So it will then implement the functionality. So that's what we are going to cover in today's video. We are going to code this part in Java. Great. So as I said, we first would be having a heap class. And it would be having a list of integer. If you want, you can make it template wise, but I'm just keeping it simple. And we also would be creating a enum, let's say of heap type, so that what we can do is we can configure whether this will be a Min-Heap or a Max-Heap. Okay, so I think this should work. Then we have the heap types, time to have a constructor, public heap. Then we will take the heap type in the constructor. Okay, we can initialize our main heap list here and initialize the type of the heap. Looks like we also need some imports here. So array list is what we are using, and list. So java.util.arraylist and import java.util.list. I think that's all what we need as of now. So okay, we are done with the constructor. Now we will move towards having various functionalities that we need for heap class. So there would be a public void. Okay, we first need to create the heap. So to create, we would be having an insert function. So we will say insert value, and then we say heap dot, it is our heap M-heap dot add, and our value, this will be inserted in the array. And then basically we have to heapify. I'm writing it commented because when I will write the function, then I will write this code. So we just want that our heap should always be in a heap format, right? So that's why we have to call heapify again and again whenever we insert something. Okay, so next can be public int peak. Peak means we just want to see what is at our heap at the moment right now at its top, right? So we can have some checking if heap dot empty. You can say throw some exception. I'm just writing returning int min, or say -1, right? Just for easy purpose. Maybe you can have some better handling, and from here we can return just mheap dot get at 0, right? So whatever is our root, we will just return it. So we are done with insert, we are done with peak. So next I think we would be needing is how do I extract the functionality from the element from heap. So public int extract, if again I can check if our heap is empty, then you can say throw some exception, return -1. We are turning -1, so I will make sure that we will put only positive integers inside the heap, right? So extract, so the root will be mheap dot get at 0. That's what we did in peak. Then last value will be heap dot mheap, basically. But remove mheap dot size -1. So we got our last value, and if our heap is not empty, then we have to perform Heapify. So wherever I am writing Heapify, I will go ahead and write the, I will replace that with the function whenever I will write the Heapify function. Okay, so let's move ahead. Next function is, let's have some basic functions like what are, how to get the parent, get parent. So you will need to provide an index. As this is a private function, I am not doing boundary checking because this is a private function. In case it is public, then you should be doing that. So we can just return index -1 and divided by 2. This is the same formula that we learned when we were learning about this algorithm. So to get the left child, you can return twice of index +1, and similarly get right child, you can just return twice of index +2. So why would we needing swap? Because we replace the root with the last element in our heap sort. So if you remember, you can check it out. So let's say I and j are the two index that I want to swap. Again, this is a private function, so I'm not writing the boundary conditions. So temporary variable I'm creating, then I will set as I will set at index I to j, and at j I will set as temp, and I think I am done. Okay, now after doing the swap, our function next would be for comparison. So we are writing this function because we have, we do not want to have a if else for Min-Heap, Max-Heap everywhere. So would be a good practice if I can just say, I will just call this function and it will return on the basis of if the heap type is Min-Heap, then do this, else do this. Okay, so our comparator function is done, and we are all now set to write the Heapify code. Let's write the Heapify functions. So if you remember, we learned two type of Heapify functions, sink and swim. So we are going to write both of them here. Private void Heapify up. So basically this corresponds to swim. All right. Okay. So let's write Heapify up. So while index is greater than 0, because we are moving towards the root, right? So, and root is at index 0. So that's why let's figure out the parent index. We can use our function that we have written. Now if, now I'm going to compare heap dot get at index, that is my current index, and heap dot get parent index. So I'm making the comparison, and if it is less, then I will just do a swap of index and parent index. Else break. No need to go up if this is doing, because we are doing the swing. Okay, so Heapify up is down. Next is to private void Heapify down. If you remember, this would be our case. Okay, so here we are going to be looping around. First figure the left child, get left child, then get right child, and get parent, and the target index. So what we will check is, so we are syncing down, right? So I am the parent as of now. I will check with my both the child, the left and the right, and see which one would be better to replace. So I will check if the left child is less than the size, that's for boundary condition, and this is needed because we are running in a while loop. It is mandatory to check for the boundary conditions and compare the left child and the right child. If this is the case, then target will be left child, and then if right child is less than M-Heap dot size, and we compare heap dot right child with the target index. This should also be target index. Then I will say my target will be right child, and then finally we are going to check if target index is not same as index, then we will just swap the index with target index. If this doesn't happen, then we are all good. We can break out of the loop. Our Heapify is complete. So we have written in extract. So here we will write mheap so last value we have set to root, and then we will just say sync down, Heapify down for 0. And similarly, I think we have done for up as well. So for insert, as we are inserting at the end, we are adding add. So what we will do, we will just do a Heapify of up, and we can give that heap size -1. Okay, so we will continue to do this. So this is all the functionality that we have learned in our first class, you can say. So this completes our heap class. Next, we will go ahead and be implementing the PriorityQueue class, and those will be very easy to write because we have already written on all the functionality that is there. Okay, so what we can do is we can write class PriorityQueue. So in this, the private would be the heap structure, heap class, because it is implementing that way. The constructor will be, again, it would take a type. You need a priority queue of which type, ascending or descending. So we can use the type here. Generally, priority queue takes higher order preference. So it's always a Max-Heap that is created for a priority queue. So we can just say this dot heap, and we create a new heap class here. So you can see that we are just using the previously written heap class for our priority queue. So if you want to push something, say you want to push something into the queue, you will just say heap dot insert. We already written insert and value. That's all. Heap is going to take care of everything. When you want to do pop, you will remove the element. You will just say heap dot extract. That's all. Heapify will be taken care automatically by heap, right? And if you need to say pick, what is right now at the root, you can just say heap dot pick. That's it. That's it. PriorityQueue class is finished. And similarly, we can have a HeapSort class. This will again be almost on the similar lines, right? So for sorting, we do not need any state to maintain. So a priority queue has a state. So we have created the heap object and iterating over it. But here we do not need any such instance, right? So we will just use the functionality of heap class for once, and then we can easily discard it. Because once sorting is done, we are not maintaining any state. We will do the in place sorting and we will just return. So we can just say public void sort the function. It will take an integer array as the input, and how you want to convert it. So you can say that this would be a in place sorting to be performed. Okay, we can create a heap object. This would be just for the lifetime of this function. Whenever this returns, the object will be destroyed. So depending on what we pass, min heap, max heap from the calling function, this will sort in corresponding order. Right. So what we will do is we will write the code to add elements to the heap. So our function to add is insert. So we will just iterate over the array 0, I is less than array dot length plus I. We will say heap dot insert and array of I. Okay. So this will create the heap. Now our heap is created. Now we will keep on extracting the element from the heap. So for I will be array length -1, I is greater than equal to 0, minus I. Now you know that whatever, if we want the in descending order, we have to put at the end. So the max heap would return as the max element, which is at the root, right? So that's why we are putting at the last. Heap dot extract. That's all. Our sorting is done in place. Now we will just have to write the testing code for this function that we will quickly write. We can write a heap test class, and we can have a public static void main function that will take string args as general for Java. Okay, so let's have a array. We can have 4, 6 in any order we want, right? Yes, this should be good. And then we can write array before sorting, and here we can write arrays dot to string array, right? And then we will just call the HeapSort class, HeapSort, new HeapSort, hs dot sort. We will pass the array and which type. Heap type will be max heap. Now we can say, quickly copy, paste after. Okay, so we will run the code later. If there are any compilation error, we will try to resolve them also. And then we can have our another array. You can say, can use the entire code basically, right? We can have another array 1 before sorting. No need to create this. This is already created. And then we will try to do in the min-heap manner. And we will just print the array 1 and pass array 1 here also. Okay, this should be good. Now we can quickly check the PriorityQueue example, right? So what we can do is PriorityQueue sample, and we can say we have to first create the object PriorityQueue new priority queue, and we have to provide the heap type. Let's say it's max, because priority queue is generally you want the max element. But if you want, you can try at your end how the min heap will work. So we can say pq.push. We can push 8. Then we can just copy it. Can say 5 elements. We can push 8 in any order. Order doesn't matter here. 5, 1, 4. But now if you want to get out something from the priority queue, you can see that we have not written the method for is empty. So let's write that public is empty, because it's good to have a function which can return. So we can return heap dot is empty. And do we have a function in heap class? No. So let's write that also. Private, it should be public. It is calling from outside. So let's write it along with public functions only. Okay, here it is. Public is empty. You can write return mheap dot empty. That's all. Good to go. Okay, so here we can write is while priority queue is not empty, we can write, we can just copy this part here. Okay. We will just getting it out, and finally we are done. So with this, let's try to run the code. Okay, so there were a few syntax errors, so I have corrected those. You will find them in the code file that I will attach with this video. And if we compile this file, .java, it is done. And then when we will run it, it will be from with the heap test, because that is the class in which main function is there. So the first one, 473 array, first is sorted in ascending order, then it is in the descending order. If you remember, I told you this work other way around. When you create a max heap, you get the array in ascending order. And when you create the min heap, you get the array in descending order. To get the intuition, I would suggest please see the video in which I explained the concept. In the priority queue, we inserted 5 elements, 8 to 514. So this is the max heap. So at the root, we have the max element. So when we do 2 extractions, it will print 8 and 5. You can see at the right hand side, okay? Because those are the 2 elements which are the highest priority or highest number when these 5 were pushed. And then 3 and 9 were pushed. And then we do the final extraction, then it comes in different order. So I think that's all for this video. Thank you for watching. I would suggest if you have any question, concerns, please put in the comments below, and I will try to answer them happily. Thanks for watching. See you again.